Okay, so this is the second and final video of Algebra 2's Unit 4, Day 2. In it, obviously, we're going to talk about this EQ2 here. What is the natural base, aka Euler's number, right? And I hate that it's pronounced Euler, but apparently that's the right pronunciation. For years, I was calling it Euler. It's named after a guy named, and I'm probably spelling this wrong, Leonhard Euler, right, or Euler. He found, long story short, that there was a number that had a function whose rate of change was exactly equal to the function itself, basically. And what that means is, well, I'm not going to get into all that, what it means. But the point is that that number is incredibly, incredibly useful. Okay. It appears in all kinds of natural things that we study, uh, that includes finance. You wouldn't think finance was, natural, but it is a whole crap ton of math. And what's more natural than mathematics itself? It appears in chemistry, physics. Um, it's pretty much always used as a way to model natural growth or decay. We talked about growth and decay in the previous lesson video. Well, the previous lessons videos, plural, right? Um, and yeah, there's a lot that's fascinating about this number. But anyway, I keep talking about it. You'll always see it denoted with a little ed, right? And again, that E stands for Euler. It also just means natural base. Okay, so it is synonymous with the natural exponential base, right? So natural exponential base. Okay, and you'll see it a whole crap ton in higher mathematics later and in any kind of business math that involves some kind of finance where you're compounding interest in one way or another. Um, yeah, Euler's number is super important. And if we look at a calculator, right, and you already see I already have this pulled up, e to the first power. Okay, so let me back up. So on the bottom left, I probably shouldn't have entered it in first. On the bottom left, we see an E button here, right? If we hit that, the calculator immediately tells us, well, what power do you want to raise it to? Well, duh, if I raise it to the zero power, anything to the zero power is one. If I raise it to the first power, this is where we see what the number actually is. It's about 2.718. Okay, it's about 2.718, right? And it's an irrational number, meaning this number goes on and on and on forever. Okay, so it's an irrational number of great importance, much like another irrational number we learned a crap ton about in geometry called pi. Pi is another example of a very important irrational number, a very important constant, right? That goes on and on forever, and everyone knows it's about 3.14, but it doesn't stop there. It goes on and on and on indefinitely. Okay, so we have learned another important constant. Okay, you're going to see this number a lot in the future, and in this class, we're going to use it a whole bunch. Anytime you see a little e like that, know that it is synonymous with the natural exponential base or Euler's number, and it's about 2.718. Okay, so that does it for this video. If you want to know more about um, the history or the application of Euler's number, the natural base, come and find me and we can talk about it some more. Okay? Other than that, goodbye.